How astronaut Shubhanshu Shukla survived 2000C fireball explained. The Crew Dragon spacecraft of the AXIOM-4 mission landed safely in the Pacific Ocean off the coast of San Diego, California, despite its charred appearance. Upon re-entering Earth's atmosphere, the spacecraft encountered extreme temperatures ranging from 1,600 to 2,000 degrees Celsius, leading to an external fire. Astronauts Shubhanshu Shukla and his 3 crewmates witnessed the flames through the windows but remained unharmed, as did the spacecraft itself. Such high temperatures, between 1,000 to 2,000 degrees Celsius, indicate an intense and destructive fire capable of turning wood, plastic, cloth, and most organic matter to ashes instantly. Metals begin to melt, and human exposure for even a few seconds could be fatal. However, the Crew Dragon spacecraft, designed with advanced technology, withstood these conditions. And when the spacecraft re-enters Earth's atmosphere from space, it travels at around 27,000 km/h. At this speed, it collides with the upper atmospheric layers, generating extreme friction. And the friction causes atmospheric molecules to collide with the spacecraft, generating intense heat and triggering fire. The outer surface temperature can reach 1,600 C to 2,000 C. However, the spacecraft withstands these extreme conditions thanks to its advanced heat-resistant technology. And to protect against this, the spacecraft is equipped with a special heat shield known as PCAX phenolic impregnated carbon ablator. This material absorbs and burns away under extreme heat, gradually shedding its surface to maintain a safe internal temperature. And when the spacecraft lands on Earth, its outer surface, especially the heat shield, appears burnt, blackened, and worn in several areas. This is an intentional part of the Crew Dragon capsule's design and advanced technology, which ensures the vehicle remains intact. Just as any object falling at high speed while burning would show signs of scorching, the same happens with Crew Dragon during re-entry. And to prevent excessive heat buildup during re-entry, a deorbit burn is performed to reduce the capsule's speed. In this process, onboard thrusters are used to control the spacecraft's velocity, ensuring it enters Earth's atmosphere at the correct angle and speed to minimize friction-induced heat. Shubhanshu Shukla's spacecraft successfully completed this maneuver after separating from the International Space Station ISS on July 14, 2025. As the capsule descends into the lower layers of the atmosphere, the heat begins to subside. At this stage, 4 parachutes deploy, slowing the spacecraft and preparing it for a safe splashdown in the Pacific Ocean. And the PCAX heat shield and multi-layer insulation maintain the internal temperature between 25 C and 30 C, ensuring a safe and comfortable environment for the astronauts. As the heat shield burns, it gradually sheds its outer surface to release heat. Beneath it, a layered thermal insulation system prevents the remaining heat from penetrating the capsule. The astronauts inside remain unaffected by the extreme conditions outside. And the heat shield will be reinstalled for the next mission. SpaceX has designed the Crew Dragon spacecraft for multiple reuses, including its capsule structure and key systems. After landing, the spacecraft is thoroughly inspected to determine which parts are reusable. The burnt outer layer of the heat shield is fully removed, and a new PCAX shield is fitted in its place. Swipe left for next video. And the rocket gradually gains speed during launch. In the initial seconds, the atmosphere is dense but the rocket's speed is relatively low. As altitude increases, the atmosphere thins and the rocket accelerates. Latest blogs.